This was pop quiz 2, which was related to simple magnetism. In the first question, a bar magnet picks up two steel balls. Which diagram shows a magnetic poles induced? So for a magnetic material, always opposite poles induced. Like example, when we check option, the first option, if this is a south pole, then this should be a north pole. So it is wrong. If this is a south, because unlike poles will repel. That's why. So if this is a south, north is there, then south, and then south cannot be like poles repel. But when you check D, north, south, north, south. So D will be the right answer. In question 2, you need the direction of a magnetic field for a wire which is carrying a current in, current out. So you have to use a right hand grip rule. So according to right hand grip rule, your thumb will represent the direction of the current. So in this case, the current is pointing out. So your thumb should point out here, and your fingers will turn in the direction of a magnetic field. So when your thumb is pointing out of the screen, like towards you, your fingers will turn around to the direction your fingers will turn. It will be anti-clockwise. And the spacing between the lines, the first two field lines should be closer. The second and third should have a large spacing, shows that the strength of a magnetic field is decreasing. So B will be the right answer. The next question, a permanent magnet is placed close to a soft iron. So opposite pole will induce as magnetic materials are always attracted towards the magnet. So if it's a north pole, so this will be south and Q will be north. So NP will be south and NQ will be north. So C should be the right answer. In question 4, example, a magnet is placed on the balance and the reading on the balance is 100 grams. If you are holding a piece of iron, like iron bar is there, so if you are holding it, what will happen? The opposite pole will induce. So this will be a north pole and this is a south pole. So which direction the magnet will move? The magnet is attracted towards. So as a result, the downward force will be less. So the reading on the balance will not be equals to 100. It will be any value but less than 100. Why? Because first, the weight of this bar magnet is acting downward and that is compressing the spring in the balance and it give us a reading. But then what happened, like example, weight is downward, but there's an upward force from, because the magnetic materials attract, magnet and magnetic materials attract each other by producing, like this will be north and south. So this will, bar magnet, we are holding a bar magnet, the bar magnet experience that attraction downward and the magnet will experience attraction upward. So as a result, what will happen? This reading won't be 100, it will be less than 100. Any value, but it will be less than 100. Same thing, if we are holding a bar magnet with the opposite poles facing each other, so they will also attract each other. So as a result, the weight of a magnet is, bar magnet is acting downward, but because there's an upward force, so as a result, less downward force, so the reading on the balance will also decrease. So in both diagram 2 and diagram 3, the reading will be less than 100. So A should be the right answer. Is it clear, this question? Anyone having a doubt in this? If it is less, if there is another. So both cases, the reading on the balance, it's A is the right answer. Both cases, the reading on the balance will decrease. Why? Because if you bring a bar magnet, this will be a north and south pole. So bar magnet is attracted. So less downward force. That's why the reading on the balance will be less. Here, opposite poles are there. So again, the bar magnet is attracted, like move upward. So as a result, what will happen? The reading on the balance will be less than 100. So A should be the right answer. If it was the opposite poles in the bar magnet, why can't above one come down? Because they mentioned we just held it closer. Like when an iron bar and another magnet is held close to the first magnet, like we just bring closer. And if it was, what if it was like this? Like poles were there. Say we have a south and north. Like poles repel each other. So weight of the bar magnet is already acting downward. And there's a magnetic force is also downward. So the reading will be more than 100. Any number, but more than 100. And if what if we have a material which is a non-magnetic material, like say this is, in this case it's a iron bar, but what if we have, like example, a copper bar is there. So copper is a non-magnetic material, so there's no induced magnetism. So the reading will remain 100. Then the V diagram shows a pattern of a magnetic pattern, shows a pattern in the direction. So it's always out from north and into south. So A is representing a correct direction of a magnetic field pattern. But why A is like pattern is correct, but the spacing is not correct. If you see, when you check the spacing, it appears that because near the poles, the distance between the field lines should be closer. So if we select A, why A is considered as wrong? Because here near the poles, the field lines are very close to each other, shows a stronger magnetic field. So in A, the field lines are not closer. They have the equal spacing. You can see like distance here, this distance here, all distance appear to be same. That's why A is not acceptable. B and D are totally wrong in terms of a direction. So we are left with C. Why C is the right answer? Because the field lines are very close to each other, shows a very strong magnetic field at the poles. And as we move away from the pole, the spacing between the field lines start to increase. So that's why A is like looking at this pattern and the direction. So direction for A is also correct. But why the pattern is wrong? Because near the poles, the field line should be closer or there should be a stronger magnetic field. Why A is wrong? Because for A, the spacing between the lines is same. Like if these two field lines, they have the same space, these two field lines have the same space. But what should happen? Near the poles, the line should be very close to each other. The spacing should between the lines should decrease, shows that the strength of a magnetic field is increasing. So because here the magnetic field lines are very close to each other, shows that there's a stronger magnetic field. That's why C is the right answer. Is it clear, this one? Then a bar magnet is placed inside a current carrying coil as shown in diagram 1. And there's a small current in the coil that a bar holds. Few nails are there as you can see in diagram 2. When there is no current in the coil, the nail drops off. Which row is correct? So it means this material is behaving like a magnet when there's a current, and once or external magnetic field is behaving like a magnet. Once there is no magnetic field, it loses magnetic properties. So what should be this metal of the bar? It should be iron. If it was a steel, then the nail should remain in contact with a bar. An effect of a large current in the coil. So if we pass greater amount of current, it will produce a stronger magnetic field. As a result, when it produces stronger magnetic field, it would attract more nails. So the metal from which a bar is made, how we identify? It's an iron, because when there's no current, the nail drops off or it loses magnetic property. That's why it is iron. And when there's a strong current, there will be stronger magnetic field. So more nails will be attracted. So the bar holds more nail. That's why B is the right answer. Is it clear, this question? Question 6. So this was about the simple magnetism pop quiz 2.